So we have a shallow soil pit here, and we want to do some basic assessment of the soil consistency or the strength. And so what I'm going to do is scrape off the face here, so I've got a clean face, and then I'll use the pocket penetrometer. This is a spring-loaded punch. I'm going to push it in so that it goes to the first ring here. That's about 1/4 of an inch deep. So I've slid this indicator ring all the way down so it's flush with the base, and I push this in so it goes 1/4 of an inch, and then that depresses the spring, and then when I retract it, the spring is or the indicator ring is here at about 1.0 kilograms per centimeter squared, also tons per square foot. They're equivalent. Okay, so that's the pocket penetrometer. What I would do is make several measurements in the same vicinity and take an average, and you would expect that the consistency would vary as a function of depth. So the soil pit is generally going to be bigger than this, and you would make these measurements as a function of depth. Another measurement that we want to make is the shear strength. This is done with a Torr vane indicator, and we've got this device that's put on the end of it. You can see these vanes. This will be pushed into the soil, and then I'll rotate this. There's a spring, and so as I rotate it, I tighten up on the spring, and eventually I'll get enough torque so that this will spring loose. Now before I do that, I want to set this dial so it's back on 0. This mobile dial here works the same as this red ring on the pocket penetrometer. So as you turn this, and then when it shears, this will record the maximum shear stress that was applied. So I turn it in a counterclockwise direction to set it, and then I push it straight into a flat face, and turn it, and then it breaks loose and shears. You can see the soil and the veins here, and I can read the value right there. Okay, so record that in the notes, and then carefully clean out the soil here between the veins and make another measurement to take a look at what the repeatability of this is. When you're using the Torr vane shear stress tester, you should be sure to note which one of these discs you use. There are 3 discs in here of different size, and each one will exert a different shear stress. So note which one you're using, and there's a number written on the inside of the shear vane. So write that down. In order to get the shear strength, you take the reading on the dial and multiply by this number here on the inside of the vane. This size right here has a number 1, so you're reading the shear stress right directly. But with this bigger vane, it's 0.2, so you would have a smaller shear stress than what is read here on the dial. So these 2 measurements should give you the consistency. Another thing that we want to do is get a sample of this soil. That'll allow us to measure the water content using a drying technique from the laboratory. And we have a couple of ways of doing that. One is to use a simple syringe that we've cut off to make a sampling core barrel. And push this back in, like so. So this is a syringe. We've cut the end of it off. And the convenient thing about this is that we can measure the volume of the sample using this. So you probably need to get this wet to get it in. Okay. So I'm going to push that out, but not out all the way, just to the very end. And now as I push this in, I'm going to retract the retract the inner plunger as I push this into the soil. And I might need to rotate it a little bit. Okay, so I have the soil sample here, and it's flush on this end, and I have 40 milliliters of soil in this plug. So that'll give me a volume measurement for calculating the volumetric water content. I'll need to take this back to the lab to dry it, and so I'll put it in the bag. I should be able to just extrude it out. So there's the soil sample. Seal it in the bag, and then we can weigh it. You get the weight of the bag, and we can just keep it in the bag during the weighing process. But then back in the lab, we'll dump this out, weigh the sample again, dry it, weigh it after it's dried. Now, some soils will be too tough to get a sample with this syringe, or we may want a bigger sample. So in those cases, we'll use a sampler that looks like this. This is a steel sleeve, and we've got sampling sleeves inside of this. So this will get pushed into the soil, and we may be able to just push it in with our own weight, but typically what will be needed is to hammer this into the soil. So we'll hammer this in using this sliding hammer, and we'll screw this on and make sure this is very tight. Best to use some wrenches to tighten it down, but this should be good enough. This is pretty soft soil. But you need to be careful when you hammer on these threads that the threads are tight. So we want to get a sample of this soil in its intact state. And I'm going to hammer this down, and so I need to clear off a flat surface that is the native soil, because that'll end up being the top of my sample. Okay, so there's a good surface for sampling. And so I'm just going to drive this straight down. Okay, so that should be good enough. Now the best thing to do is to dig this sampler out. If we hammer it back out, chances are that the sample will get pulled out of the sampler. So we can dig this out fairly easily, I think. Okay, so there's our sample back in there. We need to get this out. This is going to differ in an important way from this syringe sampler, in that we've got some inner rings that will contain the sample. So we need an Allen wrench to take off these set screws. Okay, so now it slips off, and there's the sampler. Now we need to push this out to get our samples. Okay, so here are the samples, and they're in these rings. And what I want to do now is trim the samples so that I have a known volume. So I'll use this knife and trim it off. That looks good. This side I've lost some sample here, so I'm going to trim this. This sample, there's two rings, so I'm going to pull this ring off, and I'm just going to go for this one ring. So I'm going to push that out a little bit and then trim this carefully. And what I'm going for is a sample of a known geometry, a regular cylindrical geometry that I can use to calculate the volume. So that's flush. And then this is now ready for a moisture content analysis. So I'll put it in a bag, and we don't need the ring anymore, so I'm going to push it out of the ring. And it's okay if it breaks up at this point, because we know the volume. Just need to make sure that all that soil goes into the bag. And seal it up. We need to get it to scale pretty quick and get a weight, and then dry it to get the water content. Now, to use the sampler again, we put the rings back in, and then we'll put the cap on, and we'll be ready to get another sample with it. So this one will go on and be held in place with set screws. We have another design that screws on. Make sure you have the Allen wrench to tighten the set screws. There's one set screw for each side. So that should tighten up until it's flush. There's another set screw for the other side. And then we're ready to take another sample. This is a Decagon EC5 capacitance probe. It's used to measure the moisture content of soils. I have it attached to this little signal conditioner and display, so I can push this in and take a reading of the moisture content in the field. It's also possible to hook this up to a data logger and monitor the moisture content as a function of time, but I'm just going to get individual readings right now. So this is these sharpened probes or plates right here are where the measurement is made. So I'm going to push this into the soil, push it straight in, all the way, burying those two sharpened blades, and then I just press this to make a reading. So 25.1% moisture, and then I can move it around and take multiple readings. So it's pretty convenient, and you always want to make multiple readings to get an idea about the variability. When you're done using the EC5s, make sure to pull them out straight and coil the cable up carefully. And we keep them in this storage bag. So put them back in the storage bag. There's a case for the display. So make sure the display goes back in the case and back in the carrying box. This is a push tube soil sampler. We use it to make a hole for tensiometers, but it's also really good for getting samples of the soil. You can see the profile exposed here and map the horizons in a pretty quick and convenient way. So we can push this sampler in some cases if the soil is soft, or we can hammer it in. I would recommend pushing it in no more than this far, so that the soil doesn't go up inside here. So we can go and do this. This is pretty soft soil here, and we can push it in just with my own weight. And there's a sample of the soil. It can be, in some cases you might want to scrape the sample off there, so you don't, sometimes you'll smear the outer surface of the sample, and so you scrape it, and that shows you what the material looks like. Looks like there's a little bit of a horizon change right here. And so we can get this material, we can wet it up. This would need to be wet it a little bit, and extrude it to make a ribbon, or roll it to get the plasticity. We can determine the grain size, so we can tell what kind of soil this is using the USDA classification. And we can get the color, of course. And so we can remove this and go deeper. And we can get this material out after we've described it, clear out the coring tool, and go back in this hole, and we can extend the hole deeper. So there's another set of, or the next 8 inches or so of the soil. Now in some cases you're not going to be able to push this into the soil, so you need to hammer it. The sampler simply screws on, and you need to make sure that when you are using this, that the sampler is on here tight, and that as you use it, as you hammer this, that it doesn't loosen up. So this is used like this. We push it down like this. This is very soft soil, so it goes in very easily. One thing that can happen though is this joint can loosen up as you hammer it, and you need to watch that, because if it does, if it loosens as you hammer it, you can damage the threads. So we made a small pit here to make a few measurements, and we need to be sure to leave the area in the same condition that we found it in. So as I dug the pit, I left the cuttings, or the diggings, the spoils here in a pile, and I'm going to put the spoils back in and make sure that the hole is completely filled before I leave. Soil will compact a bit after it's had time to settle, so I would compact it a little bit with my weight, and then maybe scrape a little bit of extra soil here. So I pressed it down, and it's mounded slightly, and now after it's compacted and settled a little bit, it should be flush.